Now, it's been known for a long time that productivity in the Australian construction industry is poor, and that's actually not unique to Australia, it's a world thing. What's happened recently, though, is there's been structural changes in the Australian economy, and what that has done is exposed our businesses to world labour costs, as well as cheaper manufacturing and prefabrication techniques. And one of the solutions that we're seeing here today is prefabrication. The problem with that in Australia is that may go offshore. So there's a bigger thing afoot here. Now, it's these events that are giving our industry a wake-up call, and this is where BIM seems set to be one of the enablers for a new game. But there's a very big problem. We know an awful lot about 3D modelling. We don't know very much at all about 4D, linking of time, and 5D, linking of costs. And that's what I want to talk about today, is 5D, because that's my specialty in estimating and cost planning. Now, often 5D is reduced to the simple words of quantity takeoff. And if that's all it is, then we won't know the cost of a building until the models are complete. The other thing is it's not transparent. So the estimator doesn't sit at the same table as the designers and the owner. What I think is an alternative and a better approach is for a 5D QS or an estimator to pull information from a model and then push back accurate data at the right time for that team to absorb it. This means that the efficiency of our projects gets tested at an early time before the models are complete, and that's when we have the best opportunity to influence cost. The other thing is it establishes a living cost plan, and that can be rerun. It can be rerun weekly, endlessly, and it gives real-time feedback on where costs are at. So the result is a better building, and the reason for that is because money is targeted at the most important design features, and it's done in a transparent way. And this is a key thing because it's that builds trust amongst all project partners. Now, for BIM to be truly successful, it needs to deliver on all of the Ds. So today, what I'm going to talk about is a project I was involved in and share with you the figures on that project. And then I want to suggest a 5D workflow and a methodology for how to make this work on your projects. And then we'll touch on what this means for our contracts, as well as what it means for cost savings and where this 10% saving actually occurs. So the case study is a project that we did some years ago now. And the reason why I continue to talk about it is because I haven't seen it replicated. On this particular project, it was an iconic job in terms of its design. It won a bag of awards, and there was one subcontractor that did things differently to every other one. And that was where I saw this different sort of outcome. So the project is at Southbank in Brisbane. And the area of the building work is through here. There was a significant amount of civil work that went on here. It's a very public space. The idea of the project was to bring the people down to the river. What we didn't realise was 2 years later the river would come to the people. But there was an awful lot of money spent in creating this sort of amphitheatre down to the river. Now, the designer for this project was Andrew Guthridge of Archifield, and this was the first model that he put together. When I looked at the master plans, it didn't mean a lot to me looking at, it was hard to tell what was internal and what was external. But accompanied by this sort of information, as an estimator, we got an immediate sense of what this project was about. When it was completed, it matches his first model quite well. And this is something that we know, visualization is very strong. Pictures relate to people. Now, in terms of what went on in the background, and bear in mind this design was about 5 or 6 years ago, we had a client that didn't know anything about BIM. That's definitely not a unique thing. And we also had a project manager that saw BIM as a risk, and really we shouldn't do it. And if we as consultants were going to choose to go down that pathway, well, that was our problem. The consultants that were working together, we were kind of good at what we did, but there was no such thing as a BIM execution plan at that time, so we tended to bumble along. What we did, and what is pretty common now, is to put together the different models in a federated way. The architect coordinated that design, and he did that as best he could. So this is all kind of run-of-the-mill stuff. What was unique was that there was one the structural steel subcontractor that asked for a copy of the structural steel Revit model. And from that, he built his own Tekla model, and from that, he did the fabrication. Now, this was a lump sum contract. The models weren't part of that contract. It just kind of happened. And this is why I haven't seen it replicated again since. I've been involved in a number of projects where subcontractors are involved in design and where they're producing models, but this is one where he was doing it on his own right. In terms of the build of the structural steel, it went fantastic. The rest of the job did not go so fantastic. In terms of what happened in a monetary sense, we had a blowout in time of almost 60%, and we had an increase in the lump sum price of almost 30%. There were 321 claims. The initial claims were around about $4 million. It was settled for around just under $3 million. Now, the reason for those things happening is because it was a complicated design. And while designers had done the best that they could to coordinate it, it's not the same as when you've got a contractor and the people that are building it looking at the way it goes together. In terms of the steel, there were no delays whatsoever, and there were just 5 variations. Every one of them were agreed before he started work. The types of variations that occurred there were things like move steel around to accommodate these ducts in the walls, in the wall bracing, and add some trimmers and this sort of thing. It was valued up, and he went along his path with certainty. For the rest of the subcontractors, there wasn't a lot of certainty at all. In terms of the client's perspective, they were ecstatic because the project was under budget. Now, there was 2 reasons why the project was under budget. We had a significantly low bid contractor, and then the other thing was we had a significant contingency. And we had a significant contingency because it was an iconic building. And it was those 2 things that from a client perspective, it was all good. But in terms of the project, it was not so smooth. So what I learned out of that is when we're modeling, what we are trying to do is create efficient construction. We're trying to create certainty for a subcontractor that when he turns up on Thursday, that work is going to be ready for him to do. He won't be turned away and not paid for that time when he's not there. And this is a challenging thing for designers because it's not really what they're about. The other thing I learned is that you get the right people to be looking at this type of information. So what I then did was a turn to, well, as QSs, what can we do to make costs more certain? How do we head towards the 2% rather than towards the 27%? And this came out of a couple of things. First, sitting down and describing our workflow so that people knew what we were doing. And the other one was developing new skills. And first of all, I'd like to share with you what they are. The first one is pulling information from a model. Now, this is one sector of the model for Sunshine Coast University Hospital. In terms of looking at an MEP model, it looks like any other model to us as a QS. We can abstract all sorts of quantity information, and that is a very, very simple task in terms of being able to pull information. What is a new skill is being able to map that information. Now, when I talk about a map, let me go back. We've heard today about estimates. We've heard about establishing quantities. What a map is like a search of the database. So it's like a really, really strong Google search to find you precisely the information that you want. And as the design gets more detailed, that map gets more detailed, and we find out more information. By way of example, at the outset, we might want to know what the area of the carpet is. As we progress along, we might want to know what the different types of carpet are. As we progress along further, we might want to know how many individual tiles they are and how many boxes they account for the different patterns within that pattern that's being provided. And as long as the level of development of the model progresses, these things can be driven from a map. Now, I just want to give you a sense of what this looks like when it's being run. We use a piece of software called Qsys, and it's just one of many, but it does it very well, and we've been using it for a long time. The video that we're about to watch, out of the box, Qsys does nothing, so it relies on templating, maps, and then workbooks to be able to drive this through. So if we could just run that video, please. There's sort of three phases to this. This first phase is like a viewer within Costex. So we're just looking at the model in the same sort of way as you would within any authoring tool. So we've not imported anything at this stage, but we can see what all the parameters are within the model. And again, this is something that we were doing 5 and 6 years ago. So this is not new, it's actually something that's been around for some time. The next phase is we start to import the quantities that are within the model itself, and you'll see them propagate in this area here. They are going to come in elements, so something that Qsys has used to be able to look at the actual costs. And they'll propagate through here. We'll be able to find what the area of precast panels is. We can separate those and look at them in their own right. And none of this is driven by coding within the model from the designers, nor is it driven by their families. This is all driven by dynamic links within the software itself. The next phase is we import our workbook, and it's attached to a price list, and it starts to formulate our actual price. So on this project, it was $8 million. In terms of time, this is double speed. So when we talk about real-time estimating, it is something that can be done, and it can be done extremely quickly. On some of the projects we work on, we do this weekly. On others, we do it fortnightly. It depends on what the clash system is and the exchange of information that's going on, how quickly it's moving. One of the cool things for me is this notion of it's developed visual quantity. So the capability to look at a quantity and right-click and see where that quantity is. And it changes the way quantity surveyors describe work. The next thing is called pushing information and round-tripping. So what makes those maps really robust is if we can have consistent codes that everyone can see. The problem with putting information into a model is if you put it in too early, then you've got to maintain it. So there's a right time to put information in and then let it do its thing. The types of information that we use, this is looking at some property sets. The main ones we get involved in here is trade package codes are useful for subcontractors to filter a model by trade package. We can also look at activity codes, costing codes, all that type of thing. Where we work for subcontractors, we put general ledger codes in and things like that. We use a piece of an add-in called BIM Link, which is a fantastic thing. It's been around for a number of years now, but it allows us to create instance parameters across a whole family. So you're not having to deal with one-off pieces of data, you can deal with this in mass. The way we do that is we import the information into Costex, we attach our codes to it, we export it to BIM Link, and we push it back into the model. And this is a skill that a QS needs to have in this current world. The next one is validating models. So the more and more we rely on models for our quantities, the more and more we need to know, well, how good is this model? We take a view that there's no such thing as a bad model or a shitty model. There's just models that are getting better. So what you need to do is establish systems to be able to query that model to see what you can rely on and what you can't rely on. In our business, we always estimate from models. It's the position that we've taken. Now we use a piece of software called Celebri, and this is a new skill that we developed this year, and it's only because I got an IFC guy in our office and he's very, very good at it. What he did in this instance is he's looking for where things don't clash. From a quantity perspective, if it clashes, the quantity's probably right. It just needs to be moved around. If something's missing, we haven't got enough quantity in it. So what we've identified here is Scott's come up with this gap. He lets our QSs know. They look at it, and basically what they do is they map that object into the quantity there, and then they add a workaround to make up for what the gap is, and they add that quantity on. Now this is an extremely important thing. What we need to avoid is remeasuring. If we remeasure, it's not automated. So we rely on the model, we make an adjustment. When the model's fixed, we delete our workaround. And it's a process, and we have hundreds of these things throughout an estimate. It becomes another part of the database that needs to be managed. The next one is negotiations and price transparency. This is a view in Costex, and it compares one model to another. So it can compare this week's revision to last week's. It can compare this one to 6 months ago. It might be the schematic design one. And it will report to you the precise changes between them all. What we're looking at here is one model in a hospital that had about 56 models. In terms of the revisioning time, it takes us, we can revision a whole job in 2 days. So we could do those 56 models in 2 days. And it's pretty cool to watch. It takes a number of people and set systems in terms of how we go about it, but that's what it's about now, is speed. So the methodology itself, the workflow, I've projected it as an arrow. It's skinny at the beginning, it's fat at the other end. That's because we know very little at the beginning, we know a lot at the end. Basically what we want to do is make big decisions at the beginning and really, really small ones at the other end. And I'll give you some examples on how these things work. But in terms of our traditional sort of quantity surveying tasks, concept design is, it still exists. We estimate in the same way, it's elementally. We may get information from a model. It depends on whether there is a model at that point in time. So if it's a Revit massing model, we'll get some sort of information from it. If it's SketchUp, we'll get geometry and that's it. At LOD 200, schematic design, we're still operating elementally, but what we're able to do here is start to pull the general assembly information, and that's similar to what you saw in the video earlier. It's also a time where we can start to push back codes if they're going to be of value, but they need to be high-level codes. Otherwise, you'll be constantly changing them. At developed design, we're starting to estimate at sub-elemental level. So by way of example, we're now doing cubic meters of concrete within a pad footing, the excavation, the reinforcement, that style of thing. And we can start to push in things like activity codes, and you get some fairly cool results when you move along. The next phase is at completion. There's a view in the marketplace that if you capture the as-built cost, then you've got what you need for FM. And that's just not true. Now, the reason for that is you're interested in things like the replacement cost of this building. If you demolish something, you don't insure that. So the money actually has to be filtered and classified as to where it goes. We also don't insure things like a hole, and when we look at exercises like the amount of tax depreciation, we actually use life expectancies that are driven by the Australian Tax Office. They're not driven by what a manufacturer guarantees that something will be there. The Tax Office says bricks, tin, that sort of stuff will last for 40 years, and that's as quickly as you can write it off. So there's sorts of different information that needs to be picked up then. I'll give you an example of working the concept, but really this part here is about making a building more efficient. It's looking at what that building's trying to provide and see where you can tighten that building up. The next one is the living cost plan, because that's where we start to get in this automated costing regime. And really that's what drives cost certainty. So if you had an extremely accurate model, that would make cost certain. But what makes things more certain is when you rehearse it over and over and over. So it's about estimating, rather than the old school way when we do an estimate at schematic design and then maybe one 6 months later at tender. And if they match, it's probably luck more than good management. So it's about rehearsing something and doing it over and over. At that stage where we were setting up for construction, this is the first time that we start looking at quantity takeoff. And that's because there actually is enough information in the model to then start to be doing things like trade packages. And I'll show you some examples of how they're put together. At construction, it's then setting that file up for what are the actual contracted costs. If we load if the maps are maintained and we start to load in contract rates, then you can do things like value variations. You can assess progress payments, this type of thing. So you start to administer the contract costs. An example of working the concept. This is an apartment building in Brisbane. It's got a turnout cost of $56 million. It had 286 apartments, and what we do is we benchmark every one of the apartment projects that we're involved in and even the ones we're not involved in. We're interested in what the average area per unit that building is in terms of its gross area, and then we're interested in what the saleable area is, because that's what makes the money. So the closer that 66 gets to 108 is how this project will be better financed and work more efficiently. We then compare that to a marketplace, and in this instance, we're comparing projects that are being sold for the same sort of price. So not ones that look the same, because you'll get the same answer. We're interested in ones that are being sold for the same price. And we find that there's this common area that's out of whack. So while our building overall looks okay, the common area is way too high. So if I instruct the designers to sort of tighten that up and they're successful, they'll save $6 million. The alternative is they make the saleable area bigger and the project produces more income. So it's these types of big decisions that need to be done at the outset. You won't save $6 million on a project or 10% on a project when you're at tender. You're left with mucking around with carpets and things like that. In terms of the living cost plan, this is a hospital we're working on at the moment. It's 185,000 square metres. This is looking at one quadrant of it, just the structure. The yellow is revised. Now, as a QS, what we could never do was produce quantities in the traditional format that reflected where the design was today. With this type of stuff, we revisioned that in about 2 hours. In the past, if I saw that amount of revision on a drawing, I think I'd top myself or leave, do something, but get as far away as I can from that yellow stuff. Now, basically, the system works through those, it identifies it, and it's very, very good, and it's very reliable, and it's fast. Another example is looking at alternative materials. So we start to get transparency and price. Here we're looking at a different cladding on a warehouse. It means that the girts are at different places as well, and it calculates it precisely to $151,519. Another type of thing that we're able to do is in the virtual design space. This is some work that we did with ADG. Something that, so 5D sits well with 3D, 4D sits well with 3D. What doesn't sit so good together is 4 and 5D together. So what we did in this sort of demonstration work is we married together the costs within the estimate to the program that was coming out of P6, and it was really hard to do. And it's not something that I would recommend at the moment. The only software that'll do it quickly is Vico, actually. It marries these two things together fairly well. But the problem is that costs are often based on quantities, whereas our programs are based on man hours and that type of thing. And these rates don't match what we pay in hourly rates. So it depends on where you are in the supply chain and how you position it. But if we can just run this video and we can have a look at it. Basically what we did was we exported the activities from P6, ADG put them into the model. I brought those out of the model, I married our costs up with them, and then we pushed them into another database and back into Navis to have a look at it. After all that work, what we get is like this little nice set of numbers. And myself, I'm not really sure of the value of that, but something that I did learn is how powerful it is to understand the quantity of work within each activity. And these are things that we see on sites. I'm in the midst of a dispute at the moment, which is between a builder and a petition subcontractor, which is all about the contractor saying, I want you to have 65 men on site, and the petition guy saying, if I have 65 men on site, 20 of them will be sitting on my ass and you're forcing me to incur more costs. What isn't known is what the actual quantity of work is in each one of those activities. And this is something that we learnt that we could do very, very strongly when we start to marry activities together with quantities rather than the actual time period itself. Work that we did outside of this was for a structural subcontractor where we'd linked that information together with his general ledger. So we were monitoring the cost he'd incurred to date, and then forecasting the amount of work he had to complete to start pitching at where this project was going to be in an outturn cost for him, whether it was going to be profitable at the end of the day. Last example here is contract admin, and again, this is looking at a hospital in the services area. It's about when we're revisioning these models, we just get precise information about what the change is. It's very, very clear. There isn't much argument that goes on, and we produce reports that identifies precisely what those quantities are. Married together with rates, you then get what the variation is worth. So there's an indication of what the workflow is and some examples of what this thing is about. Now what I want to do is just touch on contracts and applying this methodology, because that's what we're faced with. In just my Brisbane office, we have 430 current projects. 85% of those are lump sum. I've never seen an IPD project. We have some construction management projects. We have an awful lot of D&C projects, but they're basically lump sum projects. So the thinking is, well, how do we go about applying this sort of stuff in the world that we exist in, rather than waiting for something to occur down the track? A key thing is the BIM Execution Plan. We've learnt a lot about these today. I'm reading one on plane trips at the moment, 376 pages, and it's enthralling. There's stuff in there that I've read before. There's some other stuff that's really, really cool. When I kind of look at it I think you need to have a clear understanding about what the technology is that we're utilising, what we're trying to produce, what the people are going to do, how they're going to behave, and then what our actual process is in terms of where we're going to apply this to in construction. And if you get those things known across a team, you're a long way there. In terms of behaviour, it's how we exchange information, and that could be different for different disciplines. In terms of the level of development that people are producing, again, it could be different for different disciplines. There's an expectation that a project will always be at the same LOD at any point in time, and that's just not realistic. Even to the sense where architecture leads structure. On all the projects I work on, we're letting structure way before we're letting architectural trades. So it's actually the structures ahead. And then the same in terms of understanding which part of the project we're applying this to. And that changes. So you write a BIM execution plan at the outset, but then as new actors come to the stage, you need to relook at what those skills are and then start to reset that BIM execution plan. And if that means that you need to pay people some more money to do things, I'd say pay them and get it done, because it will produce more certainty. In terms of how we do it for a contract or a project that's about to be built, my first thing is just plan to build. I think someone earlier talked about planning BIM or something like that. Planning to build is this giving ourselves permission to not start this job as soon as I won the tender. There's an expectation from clients sometimes that they want this job underway and get it started. But often as builders, they assume that that's what an owner wants as well. The minute that we establish on site and we don't have a plan for how we're going to construct this building, we start losing money. So the resistance to start on site is the first thing. And then we start looking at, well, how are we actually going to, how can we implement 4D information within this and 5D information, so we start to get a sense of where it goes. In terms of our designers, up to this point where we're selecting our preferred contractor, or even if the contract is formed, our designers can do all the clash in the world, but they will never get it to an extent that a contractor needs. It's really then forcing onto a contractor for him to continue doing that clash, doing it from his perspective, and then pass back what he finds to the designers. And if that leads to variations, well, so be it. Those variations will be far cheaper than anything that occurs on the site. And in terms of a workflow, I think it's a far better way for this to occur. All that's required at the moment is just permission and a license. So permission from the consultants for our contractors to use those models, and a license for them to use it in that way. And it just isn't that complicated. And basically that's what we saw on the Southbank project. So the last thing I'd like to touch on is what this means for costs, because we do hear a lot about savings. there's going to be 10% saving out of this. In the UK, they're looking for 20% saving. They will never save 20%. And when they do, they won't actually realise that they've saved 20%. And the reason for that is because it's complicated. What I've tried to do on this graph here, or this table, is look at who owns savings. Because it's all about contracting, when contracts are formed, and where you are within the supply chain. So by way of example, when I was talking about improving the functional efficiency of an apartment project. Now, if we did that, and there is no contract let to a D&C builder, the owner will get all of that saving, but he won't actually recognise he got that saving because there's no price a foot. It's hard to evaluate this thing. If he had formed a contract with a D&C contractor, the D&C contractor will get the benefit of that saving. So that $6 million is a very powerful thing for a D&C contractor to have. When we looked at making documents more accurate, and the subcontractor on the Southbank project, he fits in down here. So his work in making those documents better and his construction more certain, he gets the benefit of that saving. So what I'm looking at here is who should put in the effort to achieve a saving? Because where you're placed in contracts is what drives this. And this is where I think subcontractors have a big part to play in this. You actually control around about 83% of the cost of a building. The head contractor, he's in this 14 to 15%. His margin's about 1.5%. So he actually doesn't have a lot of cash to spend on making this more efficient for subcontractors. So this is a good sense for bringing people through on the supply chain. But yeah, it's a complicated thing. I've tried to set out everything I know about the supply chain in just one sheet. So let me know whether I get that kind of point across. My final words are 5Ds here, right? And there are new skills that are needed to make this work. Those skills actually sit with the traditional skills. They will never go away. It's the traditional skills that make things happen. The technology is actually here and it's really reliable as well. You can actually teach it very, very simply, but in itself won't provide certainty. What is needed is people that know what they're doing. It needs wisdom, intelligence, and knowledge of technology to be able to use these things and work out how to leverage things best for your project. So thank you very much, and we're just a little bit late. If anyone wants a copy of this stuff, you can download it from our website.